Hello everyone. Today we are going to be learning about the Wallis formula. Now, the Wallis formula is an equation that can be used to simplify integrals that either look like this or this. So in order to use the Wallis formula, there are a few prerequisites. First, the bottom limit always has to be 0, and the top limit always has to be pi over 2. And then, n, if it is even, has to be greater than 2, and if it is odd, it has to be greater than 3. And finally, the inside has to be either sine or cosine raised to the power of n. Now, interestingly enough, the sine or cosine actually doesn't matter. For example, if n over here was 5, and n over here was also 5, these two equations would be equal. Whether the function inside is sine or cosine doesn't actually affect the value. And now you might be wondering, how come? Because sine and cosine are clearly two very different functions. And we can demonstrate why they're equal by drawing a graph. So we can first draw the x and y axes. And then we can put 1 here and -1 here. And it goes from 0 to pi over 2, so we can go from 0 to pi over 2 like so. Now, when theta is 0, cosine is 1. And when theta is pi over 2, cosine is 0. So the graph of cosine from 0 to pi over 2 kind of looks like this. And when theta is 0, sine is 0. And when theta is pi over 2, sine is 1. So then the graph of sine would kind of go like this. And they both would be cut off by pi over 2 right here. And now we can shade in the areas for both of these functions. So if we look first at the graph of cosine, you see that it's represented by this area. And then the graph of sine is going to be represented by this area. And now we can kind of see that the graphs of sine and cosine are basically the same, except that one is just being rotated by 90 degrees. So that's why the sine or cosine doesn't matter as long as the limits go from 0 to pi over 2. Okay, now let's get into the actual formula. Okay, so although the sine or cosine doesn't matter, the parity of n does. So the Wallis formula has two cases, one for even numbers and one for odd numbers. And both cases are extremely similar. They only differ by one factor. So let me show you. If n is odd, let's say that the equation you need to find the value of an equation such as this or this is star. And if n is even, then the equation you need to find the value of these two is going to be star times pi over 2. And the way I like to remember this is that the pi over 2 is going to come into play when n is even because 2 is even. So it's even, so they go together. Now you might be wondering, what is star? So the Wallis formula essentially consists of a bunch of fractions multiplied together. But the fractions have quite a simple pattern that you follow. So what you first want to look at is the number n right here. The numbers that you can use to choose for the numerators and denominators of the fractions multiplied together, they're going to come from a set. And the set is going to be from n all the way to 1. Now, you know how fractions, they have a numerator and denominator, right? So this means that every fraction needs two numbers. But what if n is odd? Then you're going to have a fraction with just a 1 in either numerator or denominator, and it's going to be left unpaired. So in this case, when n is odd, we just simply ignore the 1. We can write from n all the way to 1 and then start pairing up the numbers and then realize 1 gets left out. And if that's the case, then we simply don't use it. Okay, now I'm going to explain how we are going to set up the fraction, but it's a little bit easier to explain using an example. Okay, so let's start with this equation. So first, we need to do the checks to make sure we can actually use the formula in the first place. So the bottom limit is 0, check. The top limit is pi over 2, check. N is even, but it's also greater than 2, check. The inside is either sine or cosine, check. Okay, so now we know that we can use the Wallis formula. The next thing to check for is n odd or even? If it's even, we're going to have to be multiplying it by pi over 2. And since 4 is even, we will. So the value of this is going to be equal to pi over 2 times star. And the set of numbers that we can choose for the series of fractions that make up star are going to go from n, which is 4, all the way down to 1. So we can write that out as 4, 3, 2, 1. And the way the fractions work is that the numerator and denominator are always going to be consecutive. So we can say that these two are going to make up one fraction, and these two are always going to make up the other fraction. And the other thing is that the denominator is always going to be bigger than the numerator. So we'll just say that denominator greater than numerator. Okay, so now we're ready to start setting up the fractions. So star is equal to, from this one, we get 3 over 4. And from this one, we get 1 over 2. And then we have to remember to multiply by pi over 2. So this thing over here is going to be equal to pi over 2 times 3 over 4 times 1/2, or 3 pi over 16. Okay, so over here we have sine raised to the power of 5. Now before we get started, let's do the checks. Bottom limit 0, check. Top limit pi over 2, check. Inside function sine or cosine, check. And n is odd, but it's also greater than 3, check. Okay, so now since n is odd, we're not going to be having to multiply by pi over 2. So we can just focus on the star portion. And we know that the set of numbers that we can choose for the fractions go from the value of n, which is 5, all the way down to 1. So we have 5, 4, 3, 2, 1. And then now we can start pairing up the numbers. So we have 5 and 4, 3 and 2, and 1 is just going to be left over. So we're just not going to use that. Okay, so then since the denominator is always going to be greater than the numerator, we have 4 over 5 times 2 over 3. And that is going to be equal to 8 over 15. And that's our answer. Okay, now let's try some more difficult ones where the numbers are slightly bigger. Okay, let's try sine to the power of 8. Okay, let's do our checks. Bottom limit 0, yep. Top limit pi over 2, The function inside is sine, okay. N is even, but also greater than 2, okay. Now since this is even, we know that we're going to be having to multiply it by pi over 2. I remember how remembering this is that 2 is even, so of course it's going to go with the function where n is even. And then multiply this by star. And the numbers that we can choose for star go from n, the value, which is 8, down to 1. So 7, 6, 5, 4, 3, 2, 1. We can pair the numbers up. find out that star is equal to, since the denominator is bigger, 7 over 8 times 5 over 6 times 3 over 4 times 1 over 2. And we can simplify this. This goes on to 2. And we end up having 35 over 8 times, 8 times 4 is 32. We have 32 times 4, which is equal to 35 divided by 128. Okay, now we mustn't forget about the pi over 2 portion, so this entire thing is going to be equal to pi over 2 times 35 over 128. So we get 35 pi over 256. And that's our final answer. Okay, let's do one final practice question. So we have sine raised to the power of 9. Bottom limit, Okay. Okay, so the bottom limit is 0, the top limit is pi over 2, the inside function is sine, and n is odd but also greater than 3. So we're good. And since it is odd, we're not going to have to be multiplied by pi over 2, and we can simply focus on star. And the values of star are going to go from the value of n down to 1. So 9, 8, 7, 6, 5, 4, 3, 2, 1. We can pair it up. One is left over, so we won't use it. And the fraction will be 8 over 9 times 6 over 7 times 4 over 5 times 2 over 3. Over here, we can see that this, again, can cancel. So the top is going to be 2. And yeah, I think that's all that cancels. So 8 times 8 is 64. I got 8 from here. And then 64 times 2 is 128. And 5 times 7 is 35 times 9. So we get 315. And that is our final answer. I hope this video helped, and please let me know what topics you want to see next. See you in the next video.